Hey guys, this is the last Unit 7 review video. This one's going to be all about graphing and domain and range, okay? All right, so first thing I want to remind you is that if you have a square root, remember the base is this way. If you have a cube root, the base is this way, okay? Kind of looking at our numbers, your numbers for a square root are generally 0, 0, 1, 1, 4, 2, 9, 3, because we are square rooting the x to get the y. Your base numbers for a cube root, you have quite a few more. So if we go x and y again, you are going from -8, -1, 0, 1, +8. That's left and right from your starting point. Cube root of -8 is a -2, -1, 0, 1, and +2. Okay, so that's the originals. So for instance, if I look at A, I know that my transformation is going to go to the right 2. And then I'm going to do a vertical stretch by 3. Remember, on the test, you're going to explain your transformations like this. That's your codes. You work from the inside out. So right 2 and then vertical stretch by 3. So for instance, if I get my starting point, instead of starting at the origin, I'm going to start at +2. So right 2. I'm going to follow these numbers, but instead of going these for my up, I'm going to go 3 times as far. So for instance, if I go right 1, up 1, now I'm going to go up 3 times as far. Okay. If I go right 4, so 1, 2, 3, 4, I usually go up 2, but now I'm going up 3 times as far. So 2, 4, 6. This is my next point. If I go over 9, I go off the graph, so I do not need to graph him. This is your graph for this problem, okay? So the domain is the x's. I'm going from 2 all the way to right infinity. Remember that we do need brackets on the 2 because I'm including that point. For the range, remember my lowest number is 0. I do include that, and I go up forever to infinity, okay? That's the full problem. Let's look at B. So for B, if I look at my transformations, this 1 is outside of the cube root, so I'm going to go up 1. But that would be at the end. So let me go back and do order of transformations. We work from the inside out, so there's nothing inside. On the reflection on the outside is over the x-axis, because if all I'm doing is making the y number negative, that means I'm flipping it this way. So flipping over the x-axis. Then at the end, I'm going to go up 1 because he is not in parentheses. All right, let's get my first point. So instead of 0, 0, I'm going up 1 to start. And then these numbers are going to be my left and right, so side, and then this is my up and down. Okay, now, since I reflected, instead of going this way, I'm going to flip it. I'm going to go this way. All right, so let's make sure that we are reflecting those and going the opposite direction. So when I go right 1, I'm going to go down 1. When I go right 8, I'm going to go down 2. So watch, right 8, down 2 boxes. This is my new spot. Okay. When I go left 1, I'm going to go up 1. When I go left 8, I'm going to go up 2. So this is my new spot. My graph should look like this. Okay. Cube roots are my favorite because I don't really have to think about it. The domain and range are going to be the same. I get to go left and right forever, and I get to go up and down forever. So you are going to use double infinities. You do need all braces on those. Okay? All right, let's go to the next page. Actually, I'm going to copy these so that you guys can see them down here. You don't have to copy it, though. It's just kind of to show you comparison. All right, so if I look at problem C, inside out, I'm going to go right 3. That's this transformation. I'm going to go back to the front, and I'm going to hit these 2 things. So I am going to do a vertical compression by a 1/2. I'm also going to use that negative, which is reflect over the x, and then I'm going to go up by 2. So start inside, then do the multiplication, then do anything up and down at the end. So if I graph my first point, I'm going right 3 and up 2. So right 3, up 2 means I'm going to start right here. It is a cube root, okay? So cube root is using these guys. You have to remember that you are going to cut all of the vertical pieces in half. Okay, so instead of going up or down 1 and up or down 2, I'm going to go half as far. So let's look at that. All right, if I go right 1, I'm going to go down 1 normally. So normally it would look like this. I've reflected it down, but now I'm only going to go halfway. Same thing. Normally I would go out 8, down to, or up 2, but I'm reflecting it, so down 2, and then I'm only going half. Now, that doesn't fit on the graph, so I don't really need that at all. Let's go the other way. Normally I would go left 1, down 1, but I'm reflecting it, and then I'm only going to go halfway. Second one to the left, I'm going to go left 8, up 2. That's already been reflected, but now I'm only going to go halfway. So I'm only going to go to right here. All right, if I'm going to go ahead and draw that, should look like this. Okay. All right, again, I love domain and range for these because it's double infinities. Please make sure you're using interval notation and not saying all real numbers on this test. Okay. All right, next one is D. So square root, writing out my transformations. This in the middle is my inside. He goes first, so I'm going left 2. I'm going to do a vertical compression by 1/2 again, and I'm also going to reflect over the x again. So make sure you know you're going this way now. Starting point is going to be left 2, so we're going right here. We are going down, but we're only going half as far down. So for instance, if I was graphing this like normal, I would go up 1, but since I am reflecting it and only going halfway, normally I would go right 4, up 2, but I am reflecting it, so down 2, and then only halfway. Normally I would go right 9 and up 3. This would be my point. But since I am reflecting it, so down 3, and then only down halfway, so like a 1.5. It's a really big dot. Let me make that smaller. Down 1.5. All right, that's as much as we can fit on our graph. So this is my connection. Domain is going to go from -2 all the way to the right to infinity. This time my range is backwards. So this one's going to go down forever to -infinity, but the highest up it's ever going to go is 0. So I do want to close bracket on that one. Last 2 problems. For E, we're back at a cube root. I only have 2 transformations, so we're going to do this reflect over the x. We're also going to go up 1. So instead of this way, he's going to reflect, and I need it to look like this. All right, so let's start with the up 1. My numbers are 1, 1, and 8, 2. So if I'm going out 1, down 1 because it's reflected, out 8, down 2 because it's reflected. All right, left 1, up 1 because it's reflected, and then left 8, up 2 because it was reflected. All right, connecting this one, I have to be careful because it is an inequality. Let me change this color real quick. This is an inequality, so that symbol makes it dashed. That symbol makes it greater. So if I connect these guys with dashes, and I shade him greater, that means I'm going to be above this guy. My graph is still going to go left and right forever, so you are still going to get to use double infinities. Same thing for the y's. Even though it looks like you're only going to go up to positive infinity, you still get to negative infinity because this line right here is going to keep going down forever. It's going to take a really long time to get there, but it is going to go all the way to negative infinity. Okay? All right, last one, talking about F. All right, F only has 1 transformation. We are just going to go down 2, that's it. So we are still facing this direction. So if I start him out down 2, right 1, up 1 is my normal pattern. Right 4, up 2 is my normal pattern. Right 9, up 3 is my normal pattern. But again, because this is a less than, that means I do want it to be dash and I do want it to be less than the graph. So I'm going to connect him with dashes. I want to shade lower than the graph, but I can only go where the graph is. So I can only go on this side. All right, couple things are going to change on this. I don't get to use 0 to infinity with a closed bracket anymore. Because it's not equal to, I do not get to use a bracket. So this guy has to be a parenthesis. Also for the range, I do still get to go up to infinity. But now because I'm shaded lower, I actually get to go lower than the graph too. I get to go to negative infinity. Okay. I get to use all of the y's up and down forever. All right, that is the end of the video. If you have any other questions, please email me before this test.